With fine tuning, what you can do is you take an existing model like GPT-4o, and then you can add to it your own content, right? So this is represented, say GPT-4o is that orange bar, the little blue bar at the end, which is not to scale, might be your content, right? So you add that to it, you tell it, here's all the new stuff that I know and I want you to know about and be able to answer questions about. And now it's available. So the plus side to that is the stuff behind the paywall can stay behind the paywall because this is your model. It's an adaptation of theirs, but it's your model, and you can say you can keep that in your environment, and no one can access it except through the way you want it to be accessed. And then you keep your IP, you keep your member benefit. It's behind the paywall, et cetera. The downside to this is that it is also not timely. So you'd have to do this fine tuning all the time, and fine tuning is not that cheap. That those in numbers are approximately the kind of numbers that you pay, but you're paying on lots of content that you're sticking in this thing. And if content is created all the time, you got to keep on adding it. It's you probably don't do that every minute. You do it every night or week or month, so it's not quite up to date. And like I said, it's expensive to keep that up. So then the better model, or the one I think is better, the one that we use, is called Retrieval-Augmented Generation, or RAG. And I like this definition. I searched a bunch for a good one, and this one came from Amazon, but it's nice and short and sweet. It's the process of optimizing the output of a large language model so it references an authoritative knowledge base outside of its training data sources before generating a response. The gist of this then is it can run a search, find the results of the search, and then use those in the moment to answer the question. So it has this massive store of knowledge that it already knows from its training data set, right? Which is the most of the globe filled with orange on my earlier slide. But then it can add just a little bit that's important to answer this question if it can do a good search. And it does the search against this content that's behind the paywall or is copyrighted, owned by whoever it is, hopefully, that's hosting this RAG version of the LLM, right? So the search now becomes a very important part of this. There's kind of two kinds of searches that are really in use today. One's called lexical search, which is kind of what you'd be used to with Google, where it's mostly based on the words you used. And things like Google and even simpler search engines are good at saying, synonyms or root words, or cat and feline are the same thing, or kitty and cat are the same thing. Like, it knows that sort of stuff. It knows, if you add an ly, it's kind of the same word as without it. It knows relationships between words to some extent. So it'll say, if you do a search and it sees this word a lot, it probably gets more likely to be in the higher parts of the results. If you have two words and they're next to each other a lot, it's more likely to be there. So it really is the words used and then the relationships, proximity of the words used, and of course all the synonyms and all that kind of stuff that really gives you your results. And that's pretty good because it's a fairly sophisticated model. But the thing that's kind of a bummer for that is that you all you've been doing prompt engineering for decades, and you may not realize it because we didn't call it that, but there are people who are better at Googling things than others, right? I'm better than my mother, let's say, at Googling things because I do it a lot. And so I'm used to phrasing my query in a way that's going to give me the best results. Like, if I know what I'm looking for has a weird word in it, especially in Outlook, I do this. If I know that's like some word that I don't use very often was in that message I'm looking for, I can just search for that word and it will likely find it very quickly because it's a lexical search. The other type of search is called a semantic search. And a semantic search is more like a concept. It's not quite a concept, but it's more like what the words represent as opposed to the literal words or their proximity or synonyms. So that type of search is better for like questions as opposed to, prompt engineered search terms. So the way I typically talk about this is using one of these two diagrams, depending who I'm talking to. So the diagram on the left looks like a face, kind of like a lion's face, I feel like, but I don't know. And I'll talk about it this way to people who are not super technical. is this represents kind of like Face ID. If you ever seen Face ID from iPhone represented graphically, it doesn't actually know what your face looks like necessarily. It has points that represent key points on your face, right? So it takes a picture of your face and it says, oh, the nose is here and it's this long and this wide and it tapers here and the cheeks are here. And, so it kind of represents it in something like this, although it's really numbers. Each of those points is a place in a three-dimensional diagram, and each of the lines is a vector, which is like a direction in 3D space saying how they relate to one another, right? And this is all just done through numbers like between -1 and +1. And so my face might look like this, and it might just be in reality stored as a collection of numbers. And then when I go to log into my phone again, it does the same calculation and it says, yeah, that's close enough. Anyway, the very simple 3D representation of a face is how I think of these systems representing a concept. And then the one on the right is this comes from this thing called TensorFlow. And essentially what it's done is it's taken all the words and it's represented them, in this case, in 3 dimensions. It's actually way more dimensions than that. But what this is saying is these words are represented in this sort of way. So we've got orange, obviously. I put that in there. And then I said, oh, what comes up? Now, when you use TensorFlow on the web, this thing is spinning around because it's trying to show you different things, and words get bigger and smaller and closer and farther. Last time I did this, Detroit was the biggest word next to orange. I was like, Detroit. And then I was like, oh, yeah, their baseball team is orange. So maybe that's why. So you'll see Milwaukee. But this is a little bit more sophisticated representation of how this works. And so you could represent the English language this way, or any language, or you can represent phrases, you can represent all kinds of stuff. So this is again a very simplified version of what it really looks like, a little more complicated than the other. But if you have a given concept, you can simplify it down to something closer to the face, right? And so the reason I'm telling you this is because the sort of search that we have in our product now is a lexical search. What you're used to with Google is probably something in between, but mostly, at least historically, was a lexical search. And that's probably what you see most often when you're using Outlook and you want to find an email, those kinds of things, they tend to be lexical searches. But the new way is to do it this way. And I say new way, it's not really that new, but it's become less and less expensive and easier to do over time because of AI. So what we can do is we can ask an LLM, we can give it a phrase, and it could turn that phrase into, let's say, this face, and then I can search by face instead of searching by phrase. So the way that works, and this is where it gets a little in the weeds, and this is kind of representing how we do it. So you've got your data sources, your content, right? This is all the blog posts and the discussion threads and the library entries and the volunteer opportunities and events and so forth. Those flow in, and this is the same today. It flows into a search ingestion pipeline. But now what we do is we have to take that thing and we have to chunk it. So in the lexical thing, you don't chunk it because you say, well, I want to know if these words that the person is searching for, how often they appear as part of the algorithm, how often they're together, how far apart they are when they're not quite together, all those kinds of things. So you want the whole piece of content. It searches through the whole piece and says the whole piece of content and says, all right, this is probably the best one because it's got the highest score, and we're going to put that first. Here, though, because it's a concept, you can't typically represent something like a 100-page paper with the same sort of concept that you'd represent a sentence, right? So if I say, who is Rob Wenger, that's a simple sentence, and it could turn that into a simple thing. But then if there's a whole massive paper where I'm representing once, and I try and represent that as one face, it's not really going to work, right? The face would be whatever the paper's kind of about from the summary. It can't do much more than that. So what we have to do is we have to chunk it. So if content gets too big, we break it up, and let's just call them paragraphs. It's not exactly that way. Nothing's that simple, unfortunately. But you break it into, let's say, paragraphs, send it through this embed function, which goes to the embedding model, which is an LLM. There's some tuning that goes on. That's what the little gears represent. And then what comes back is a face for each chunk. And then we store that in the search engine with the face chunk, the data, and metadata about it. So for example, the security that's around this document, so who can access it, right? Where it lives, a link to its original value on the community site or website or whatever. So all of that is put in these chunks or put into the search engine. And then when a human comes in and does a search, you take your user input, use the same embedding model to turn the question into a face. And I'm using the word face. Just no, it's not really a face, but I like to represent it that way. So it turns it into the face. It then compares all the faces in the search engine, comes back. Oh, look, here's all the faces that matched. And then it can take that and turn it into an answer. So what we've done here is we've said, okay, Rob asked this question. It's represented by this, matrix of numbers. We're going to look for a similar matrix. We're going to, come out with those that match. Maybe it's 3, 5, 10, 50, however many. Usually it's a relatively small number though, because the smaller the amount of context you give an LLM to answer a question, the more accurate it's going to be, at least given that context. So puts that all there, takes the user input, mashes it up with the prompt that we write to make it give an answer. That generates the prompt at the top. It goes to a regular LLM like ChatGPT, and it says, here's all the pieces, and it uses that to generate an answer. So this is the flow. Now the part I did on the first screen, this happens all day long as pieces of content are added to the system. So this is not real. This is near real time. It gets, you save a document on our system or any system like this. It goes through this process within, say, a minute, and then it's there until you change it or another one comes in. This process happens in real time, and then this process happens in real time. So you're sitting here waiting. When you're the user and you type in your thing, you hit enter, it's got to go through all of this to come back to you with the answer. And that happens in real time.